Welcome to the Spectrum Dominance presentation and demo video. What we provide is a hardware-agnostic means to command the frequency domain. We do this by utilizing the Common Framework Environment, also known as CFE. But before we go diving into any of the specifics in the next demo scenarios, I want to give you a bit of background information so you can appreciate what's going on. Every day we use radio frequency energy, whether it's to make phone calls, track location on GPS, or simply to listen to the radio while driving down the road. This is what we call a spectrum. On the x-axis, we have frequency, and on the y-axis, we have a measurement of power. On the left graph, you can see that there is a peak at the 4 MHz point, and that correlates to this point over here on this graph, where the magnitude is instead indicated by the intensity of the color. And what they all depict is showing energy out in the RF spectrum. Being able to listen and being able to act upon the RF spectrum breaks itself into two key concepts: electronic surveillance, which is the ability to listen, and electronic attack, which is the ability to act upon. But we all know from any social interaction in life that great communication is built off a foundation of excellent listening. When we listen to signals that come out of the spectrum, we can begin to understand how they're constructed. But surveillance is only part of electronic communications. Electronic attack is using the information gathered through electronic surveillance and performing a technique. The purpose of these techniques include jamming, spoofing, or exploiting cybersecurity weaknesses through a radio frequency interface. So this brings us right back to what is CFE. CFE performs two major functions: to tie the software-defined radio to a computing device which utilizes its capabilities, and also to supply a large variety of EA and ES techniques. When you combine both of these functions, you end up with a powerful, hardware-ambiguous solution to many radio spectrum problems. And this brings us to the first demo of the video, where we will show you some of CFE's capabilities against a DMR. A DMR is a digital mobile radio. They are very capable and reprogrammable radios that can be used for group voice communication or text communication. In this demo, these two radios are having a conversation, the details of which are potentially interesting to us as the CFE operator. Below each DMR is their respective physical screens as they would appear in your hand. And right above this gentleman's head is a spectrum on the left and a spectrogram which measures frequency and power over time. Initially, the CFE operator waits for a detection of the DMR signal. Now we can command the space where the DMR resides in. In the operator screen above the man's head, you can see that he's changing parameters and then entering the execute command to start transmitting a technique against the DMR, which will show as an active phone call made to the DMR on the left. This isn't just going to happen to a single radio though, this can happen to both radios. The reason why this is possible though is because the push-to-talk radio signal was detected and the individual components which make up this signal can be remade. For example, in this signal we can see that it is FSK modulated and is coming in bursts of information. CFE can detect both radios and identify them as separate radios. From here it is possible for CFE to tune to those specific frequencies and listen to the contents of the radio conversation. Beyond listening, CFE can save this audio data for later processing. However, if after listening to the conversation, it is to the benefit of the operator to disallow further communication, CFE can send a signal to the radio and disable it. This is possible by exploiting cyber vulnerabilities. As if the people on the other end of the radios weren't already having enough problems, the CFE operator can also send text messages to the target radios if they so choose. We chose domination today. The left radio is about to receive some unwelcome news from the operator. And this concludes the DMR demo. Up next, we have the demo of Pro Machina. With Pro Machina, we can demonstrate two key abilities. One is to take information from airborne signals and map them out, and the second is to be able to transmit a mimicked version of the same signal out into our environment. Similar to how ADS-B works, this information is all contained inside of an individual signal. The signal is a single FSK signal, which can be seen on the screen. To demonstrate electronic surveillance capability, CFE can detect the FSK signal and then extract the air traffic information from it. But as you can see, it's not just mapping the current location of each of the targets.
Pro Machina is also plotting the most recent known positions.
But sometimes we do not just want to survey. In this case, beyond surveillance is an attack. It is a capability to transmit a signal which will add new fake aircraft to the tracking screen. That concludes the demo for Pro Machina. Up last, and certainly not least, are the general jamming capabilities that CFE has to offer. Consider again the spectrum of a hopping signal. Without additional information, this signal could be a variety of threats. A commercial or tactical military radio transmitting positional or other information. With time, information, and surveillance, this signal could be identified and potentially decoded and spoofed. But it also may be the case that instead of spoofing or processing this signal, the mission is simply to deny the target the ability to communicate effectively. We can accomplish this by using a radio frequency jam. Jamming means to broadcast at the same time and frequency as the target, so that the target's receiver will hear our signal instead of the intended target signal. For our purposes, this is broken into two types, a wideband jam and a hopping jam. In a moment, you'll be presented with a simulated red radio interface. The bottom screen represents the target transmitter, and the top screen represents the target receiver. The simulated interface does transmit over the air, and because it is simulated, it allows us to see how much of the data is received. As you can see, when we perform this jam, the throughput reduces down to 0%, indicating to us that we've succeeded in limiting their capabilities. Our CFE interface is able to detect and process this signal because it is a well-studied commercial radio. In this example, this allows us to identify the frequencies of interest. This information is all that is needed to start the jamming process. In this case, we need to jam 433 MHz, and a 5 MHz bandwidth will be enough to jam the signal. Watch now the target's receiver side as the jamming begins. On the target receiver, the jamming is very obvious. The threat signal throughput drops to 0% as processing is no longer possible with the much louder jamming signal. This is a positive result, but has several drawbacks. For one, this large of a bandwidth for a long time requires a large amount of power. 2, this is a very obvious jam. With the right equipment, it would be very easy to detect the source of the RF jam. To be more subtle, we may want to use a hop jam. The setup for this scenario is the same as the last. On the CFE side, instead of the wideband jam, we will instead use a hop jam. This capability allows us to transmit energy only during the time-frequency pair that the target is transmitting energy. This is a more efficient jam from a power standpoint, and more difficult to identify and detect from the spectrum alone. As you can see, the hop jam also drops the processing throughput to 0 while being far less obvious on the target's receiver. Shown now is a commercial drone video feed. The drone will often be flying and sending video back to the handheld controller. Using CFE, it is easy to detect this video signal. It is a wide signal steady in the time and frequency. It is possible to intercept and read this video signal. It is also possible to deny that target the ability to receive this footage. By using a wideband jam, CFE is able to disable this video feed, showing again that with the right tools, an operator has the ability to control the RF spectrum. That concludes the demo scenarios in this presentation. Thank you for watching. I'd now like to open the floor up for any questions that you may have.